Section 4.1, Polynomial and Rational Inequalities. We have talked about inequalities in a past unit. We solved linear inequalities. Remember, the symbols are less than, greater than, less than or equal to, or greater than or equal to. Those are inequality symbols. When we solve inequalities, there are infinitely many solutions, so we cannot list them all. And so if you remember when we did linear inequalities, we shaded the solutions on a number line, and then we wrote the interval notation. So for example, if we came up with x is greater than 3, we put 3 on our graph. We shaded all the numbers greater than 3. We used parentheses because there was not an equal to bar. So these two symbols use parentheses. And if there is an equal to bar, then you use square brackets on the number itself, but the other end will be infinity, which will have parentheses. So our interval notation here, 3 comma infinity. So we'll be using some of that information again in this lesson, but instead of linear inequalities, we're going to start with polynomial in this first video, and then I'll do a second video on rational inequalities. So by polynomial, we are basically just meaning degree 2 or higher. So because we've already covered degree 1, that was the linear, so these might be degree 2, 3, or 4 polynomials, and they will have the inequality symbol in them. So there are quite a few steps involved. It's going to seem like a lot when you read through the steps, but once you start practicing, it's really not as bad as it seems at first. So step 1, get 0 on one side. Step 2, replace the inequality symbol with equals and solve the equation. So this part right here, solve the equation, is going to involve using methods that we have been learning along the way. Step 3, place solutions on a number line, dividing it into intervals. Step 4, test a value in each interval to determine true or false. So you're going to substitute into your inequality, determine if that statement is true or false. And then, step 5, shade the true intervals. So you are shading the solutions. And then here is the information we just reviewed, that parentheses indicate a number is not included. Square brackets indicate the number is included. And the last step, write the interval notation for the shaded regions. So let's practice going through those steps here. The instructions say solve, graph the solution set, express the solution set in interval notation. So let's look at our problem. And it's kind of good to go ahead and look at the degree right away. We see that the degree of this polynomial is 2. We could also call it quadratic. Remember, polynomial is just a very general term. And so if you wanted to get specific here, you could say this is a quadratic inequality. All right, so step 1, make sure you have 0 on one side. We already have that in this problem, so we can skip step 1. Step 2, replace the inequality symbol with an equals. So now we have a quadratic equation. And it says also in that same step, solve the equation. So if I'm going to try to solve a quadratic, the first thing I would try, I cannot use square root property here because I have an x term. So I would try factoring. And I do not have a GCF. I have a 9 in front, so let's try AC. 9 times negative 2 is negative 18. Factors of 18 that subtract to be 3. We have those, 6 and 3. Signs are going to be different, larger, positive. So a positive 6 and a negative 3, those will work. Thus, we can go ahead and solve by factoring. We're going to replace the 3x with plus 6x minus 3x, or you could have those in reverse order, and then factor by grouping. So I'm going to pull a 3x out of the first two terms. And I don't see a common factor with the second two, so I'm just going to pull out a -1 out of those. And that's going to work because I do get a 3x plus 2 in the parentheses, which is what I had in my first set. And now I can pull out that 3x plus 2, which leaves me 3x minus 1. Keep that equal 0 on each step. And now we're ready to set each factor equal to 0. And solve. So we're going to subtract 2 and divide by 3. And here we're going to add the 1 and divide by 3. So we get -2/3 and +1/3. Okay. Step 3. Place the solutions on a number line, dividing it into intervals. So I'm going to come down here below, draw a number line, and we're going to need 2 tick marks on there. We're going to need to put these least to greatest, so -2/3 should come first, and then 1/3. So we have divided the number line into 3 intervals. We have this interval on the left, this interval in between our 2 solutions, and then an interval on the right. So 3 intervals. Now step 4 says, test a value in each interval to determine true or false. So we're going to need some more space here. So I'm going to start by picking a number in the far left interval. So anything less than -2/3. I usually try to go to the integer that would be directly left of that, which would be -1. But you could do -2, -3, -5, -10, any of those numbers. Okay, but anything left of -2/3. So I'm going to put a note here. These are the test values. And we're starting with -1. We substitute it into our original inequality. So for each x in the original inequality. And just like it says greater than or equal to 0, that's what you should write over here. And then you're going to calculate. So order of operations, exponent first, then multiply. 9 times 1 is 9. You could go ahead and combine -3 minus 2. And now 9 minus 5 will be 4. So it says 4 is greater than or equal to 0. And you're going to determine if that's true or false. And it is true. 4 is greater than 0. So we put a T for true. And we're going to actually come over here to our number line, and we're going to put a T. Actually, we'll put a different color there. Above this left interval. That T means every number in that interval would make our original inequality true. We only have to test 1 to know what would happen for all numbers in that interval. Okay, so then we move along to the interval in between. Now, we've got a negative number and a positive number, so certainly 0 would be in between. And anytime you can choose 0, go ahead and choose it, because that's an easy one to calculate. So 9 times 0 squared plus 3 times 0 minus 2. And we still need to write greater than or equal to 0. When we calculate that left side, it's just going to be -2. So now it says -2 is greater than or equal to 0, and that is false. So then we're going to come back over here and label in between as false. And then we have one more interval to check. So we're going to the right of 1/3. We could take a positive 1 or any number further out. I'm going to use 1. So we've got 9 times 1 squared plus 3 times 1 minus 2. So 1 squared is 1. So it'll be 9 plus 3 minus 2 is 1. So 10. 10 is greater than or equal to 0, and that is true. So we've got true for our third interval. So let's go over that again, what we just did. Okay, once we make our number line and we put our values on it, then we have to pick a test value from each interval, substitute it into your original inequality, and determine if that is true or false. Okay, step 5, shade the true intervals. Determine whether the solutions from step 2 should be included. So let's go ahead and shade the true intervals. So we're shading this interval on the left. We're shading this interval on the right. Now, to determine whether these x values should be included, we look at our inequality symbol. Because it had an equal to bar, then they are included because they actually make this left side equal 0. Okay, so that means use square brackets, put them right on the tick mark towards the shading. So on each one, a square bracket towards the shading. It means we're including those as solutions. And that is, again, because of the equal to bar. That's what caused us to use the square brackets. Okay, and then the last step, write the interval notation for the shaded region. So we'll start at the left. It's negative infinity all the way to negative 2/3. Use your square bracket there, just like on the graph. Union, and then square bracket 1/3 to positive infinity. So all of this represents our solution set. We've shown it 2 different ways. We've showed it graphically and using interval notation. So remember, when you're solving an equation, you're solving an inequality, any value that makes it true is a solution. Okay, so if you weren't sure that you did the problem correctly, you could pick some other value in one of these shaded regions, something different than you already tested, plug it back in and make sure that it is true. Okay, so we're going to keep practicing. The more we do, the more you'll get the hang of it. Number 2. So back to step 1, get 0 on one side, which we do not have here. Now, when we get 0 on one side, we want the term with the highest exponent to be positive. And it is currently positive, so we don't want to move it. We're going to leave that x cubed on the left. So we'll leave the x cubed plus 3x squared on the left. Let's subtract the x, subtract the 3, so that we get 0 on the right side. Okay, step 2, replace the inequality symbol with an equal sign. And solve the equation. Now this is 3rd degree. Okay, we'll make a note of that over here. This is a degree 3 polynomial. Now certainly we can still try to solve by factoring. If it would not factor, then we would have to list the possible rational zeros and test with synthetic division. Since it's 3rd degree, you can't just jump to quadratic formula or completing the square. However, let's go ahead and try factoring. We've got 4 terms, so we're going to try to factor it by grouping. From the first two, we can pull out an x squared. From the second two, we can pull out a -1. And now we've got this x plus 3 in common, so let's pull it out. And that leaves us x squared minus 1. So grouping did work. Now let's see if we can factor further. We have a difference of squares. So let's keep going. X squared minus 1 will factor into x plus 1, x minus 1. Okay, now it's completely factored. Set each factor equal to 0 and solve. So we are going to get 3 solutions. -3, -1, +1. And those are going to go on the number line. So we're going to need 3 tick marks. And we want them least to greatest, which they happen to be in that order already. So -3, -1, +1. Okay, the next step is to choose test values. So we'll do that over here. This time we have 4 intervals that we need to test. So we'll start on the left. We need to be left of -3. So I'm going to go ahead and do -4. And we could either plug back into the original, or we could plug into this step where we already have the 0 on one side. That may be easier for you because 0 is an easy number to compare to determine true or false. So I think I'll go ahead and do that, but you know, on your own paper, you can do it whichever way you want. I'm going to plug test values into the form that already has the 0. All right, so we're going to have -4 cubed plus 3 times -4 squared minus -4 minus 3, and then less than 0. Okay, so a negative cubed is still going to be negative. 4 times 4 times 4, so -64. Doing exponents first. -4 squared will make +16. Here we've got negative, negative. That'll become a +4. And then let's rewrite our -64, and let's go ahead and do 3 times 16. That would be 48. And then if you want, you can combine 4 minus 3 to be 1. So -64 plus 48 is a -16. Plus 1 would be -15. -15 is less than 0. Certainly that is true. All negative numbers are less than 0. We'll come back and label our number line after we're finished testing. All right, so the second interval is between -3 and -1. There is an integer in there. Just one integer fits between those, and it is -2. So let's go ahead and test -2. I need to scoot that over a little bit. Okay, -2. Now, there may be problems where you cannot choose an integer. Let's say it had been a -1 and a -2. To get in between those, we'd have to take -1.5. So sometimes you do have to choose a decimal. Okay, so we're plugging -2 into the second step here where we have the 0. So it's going to look like -2 cubed plus 3 times -2 squared minus -2 minus 3. All right, so -2 cubed will be -8. -2 squared, +4. Negative, negative, that'll be a positive 2. And now we're going to multiply. 3 times 4 is 12. 2 minus 3 is a negative 1. Negative 8 plus 12 would be 4. Minus 1 is 3. So now it says 3 is less than 0, and that certainly is false. Okay, third interval. We need a number between negative 1 and positive 1. We could certainly choose 0 there. Let's do that. And back into our function. So it'll be 0 cubed plus 3 times 0 squared. Did not mean to put the parentheses there. 3 times 0 squared minus 0 minus 3 less than 0. So it's going to be 0, 0, 0 minus 3. That whole left side then will be just a negative 3. And negative 3 is less than 0. That is true. So I'm going to go ahead and label because I'm running out of room here. We'll turn to red. The first interval we tested with negative 4 was true, so this is T. The second interval was false. The third interval, true. All right, now I'm going to have to do some erasing because we've got one more interval to check. So we can fit that on our screen here. I'm going to erase a little. All right, so think about what value you would test. It needs to be a value that's to the right of 1. So probably most of you would choose 2, but you could choose 3, 4, 5, 10, 100, anything to the right of 1. All right, so we're plugging it in here again. So it's going to be 2 cubed plus 3 times 2 squared minus 2 minus 3 less than 0. 2 cubed is 8. 2 squared is 4. Negative 2 and negative 3 will make a negative 5. So now I've got 8 plus 12 minus 5. That's 20 minus 5. 15. So it says 15 is less than 0, and that is false. Okay, so last interval false. So on number 1 and number 2, the true false have alternated, and that actually does occur most of the time, but not every time. So you still need to go through the work of checking. Don't just find the first one and then alternate, okay? Shade the true regions. So we're going to shade this first region and shade between negative 1 and 1. And then we have to decide, well, what about these values that we got when we solved? Well, look back at your symbol. It does not have an equal to bar on it. That means these values are not included. They make it equal 0. And since there's no equal to bar, they are not solutions. So we need parentheses on the tick marks towards the shading. Okay? No bar means parentheses. And then the last step, write the interval notation. So negative infinity to negative 3 union. And then this second interval would be from negative 1 to 1. You're only putting the shaded intervals in your solution set. So all of this is our answer. We've got the solution set on the graph and then in the interval notation. Okay, so hopefully you're starting to get the hang of it. We are going to do one more example of the polynomial inequalities. So this one is back to a degree 2 polynomial. also known as a quadratic. It does already have 0 on one side, so we're going to go to step 2 and replace the inequality symbol with equals. And now we want to solve the equation. We cannot use square root property. Let's try factoring. So it has a 1 in front, which means we don't have to go all the way through all the AC steps. We know that it's going to be x and x in front. And we need factors of 1 that add to be 2. Well, 1 and 1 will work. Same signs, both minus. And if you're not sure if that's correct, go ahead and FOIL it and make sure it gives you this back. So outside negative 1x, inside negative 1x, together adds to our negative 2x. And then last, negative 1 times negative 1 is positive 1. Okay, so we really don't need to set each factor equal to 0. Let's just pick one of them, and we get x equals 1. If we did the other one, we would still get x equals 1, but we can only put 1 time on the number line. We can't put 1 in 2 different positions, okay? So just 1, that is it, which means you only have 2 intervals. So you're going to test a number to the left of 1. So I would choose 0. And so we're going back to our original here, putting in 0 for x. There's a less than 0 on it. So when we calculate the left side, 0 minus 0 plus 1, that whole side will be 1. So now it says 1 is less than 0, which is false. So the left side's false. Let's find the right side. We're going to pick a value to the right of 1. So I'm going to take 2. Back to my original. Plug in 2 for each x. Work that out. 4 minus 4 plus 1 is 4 minus 4 is 0. 0 plus 1 is 1. So it says 1 is less than 0. And that is also false. So it's false for the left interval. It is false for the right interval. So that's why you do need to go ahead and test every time, not just assume they will alternate. So the solution set is represented by the true intervals, but we don't have any true intervals here, okay? So we do not have anywhere we need to shade. We do still need to think about the number 1 itself. X equals 1, is that number a solution? Well, 1 causes this whole left side to equal 0, but because there's no equal to bar, it is not a solution. It should not be included, okay? So the numbers to the left are not solutions, to the right are not, and 1 itself is not a solution because there's no equal to bar. That means this problem has no solution. And I just want you to write that, box it in, and that's it. That's your answer for this one. There's no shading and there's no interval notation. If there had been an equal to bar, then x equals 1 would have been the solution. There would have been only one solution, and it would be just that single number. Okay, so if you want to go ahead and practice the polynomial inequalities in the homework, you can do that, and I will make a second video to cover rational inequalities.